Good morning. Good morning and happy Tuesday. Welcome to the OscopeWizard. I'm Gabe, the OscopeWizard. You have made it to the techno lair to hang out with me for about half an hour while we do some nerdy stuff, probably make some measurements, maybe build something. It might even work. We are in the middle of a quest to build a Sonos Style DIY amplifier, and that is going pretty well. And I take it as a good sign because I was listening to a record in the background and it ended as I hit the intro button. So I think the day is going to go well. The stars are aligned. Everything is going forward. We were listening to Kishibashi. It's kind of a cool record. It's got black and brown. You know what? I can show it to you. I have that technology. I can show you the record. I'm always interested in how these albums look. It's kind of a lost thing, but you can see it's two colors. It's black and kind of gold. Oh, it's gold. It looks brown in the dark, the dimness, but over in the light here, I can see it reflects gold. That's pretty cool. So I was listening to that. It's called Sonderlust. It's a made-up word, which is kind of crazy. But it's a good album if you hadn't heard it. So, it was just Father's Day this past Sunday. I had a good day, kayaked a little bit. Before the show started, you saw me blowing up a kayak. If you joined early, if you didn't, I'm letting you in on a secret. There was a clip of me blowing up a kayak, and we got out on our little neighborhood pond and rode around in the kayaks. What'd you guys get up to for Father's Day here in the U.S.? It's not as good as Father's Day in Germany, which I've only gotten to experience once, but as I lamented before, we just do not have the beer garden infrastructure to support a German-style Father's Day, maybe one day in the future. But it was still a great day. Had some Eggs Benedict, the most decadent breakfast that I could think of, and it was awesome. Hopefully, you had a wonderful Father's Day as well. I am now going to get started with our project because we have a lot to do. I hooked up the DAC in the last episode to my Raspberry Pi Zero. I got some signals coming out. I got sound going through one of my little speakers that I have. Now I need to hook that system up, so the Raspberry Pi, the DAC, up to my actual audio amplifier board and retune the outputs, because I tuned them. I tuned the amplifier outputs initially to my phone, and I wanted to look and see how close is my phone's audio output, so that the audio output on my iPhone to the audio output on the Raspberry Pi and digital to analog converter chip. I suspect, strongly suspect, there is some difference. So, the outputs won't match. We're going to have to redo them. That's okay. We have the technology. We can look at it and make all of that happen. Let's go over the setup really quickly. So, I have my Raspberry Pi Zero. I have my DAC chip. I have my amplifier. This amplifier was tuned before, so I used these potentiometers on this amplifier right here, these little guys right here. I used them and tuned the outputs so that it wasn't overdriving, but I did that based on the audio output from my phone, which I suspect is a different voltage level than the audio output coming from my digital analog converter. So right now I have a probe hooked to the output of my DAC, and I also have some digital lines hooked up to the DAC as well. I don't know why my webcam won't focus on that. I have battled with my webcam, and I'm giving up. My webcam wins this round. I would just say I'll get a new webcam, but that is almost an impossibility right now as the world stands. So I am going to look at the signals on the scope. So right now, I have channel 1 on my oscilloscope plugged in to the analog output of my DAC. And I'm also going to plug in channel 2 to the analog output of my phone. So I have my phone, let's see, if I go back over to my setup here, I have a little 3.5 millimeter adapter that I have wired up to a cable that, well, I have a real mess on my hands, that I have plugged my probe into. So this is my probe connected to this 3.5 millimeter adapter. That 3.5 millimeter adapter has a second adapter since we've made some bad decisions regarding headphone outputs on our electronics. I feel like as a human race we can all acknowledge that was probably a mistake, but all in the name of trying to sell Bluetooth headsets. And those things have sold like hotcakes. But today, I'm not that interested in Bluetooth headsets. I'm way more interested in the analog output. So let's go back. So now I have 2 probes plugged into my scope. You can see channel 1, channel 2. And I am going to look at those signals on my oscilloscope. The chat says, if the webcam can't focus, it probably just needs some Adderall. Yes, yes. We should probably be dishing out Adderall in buckets to the populace right now because I am having a lot of trouble focusing myself. That is a very good point. That webcam is hopeless. I cannot recommend it to anyone. And I don't know if it's the webcam's fault or if it's my fault. Let's assume it's my fault. First step on using a piece of test equipment as we scatter around and try to figure this out. First step, preset. So I am going to preset the oscilloscope because I don't know what I was doing last, but I can tell that it was something weird. Something weird was happening. Now I have channel 1 connected to my DAC output, and I would like to get my DAC output doing something. So if I go over to my desktop here, I have the interface for my Raspberry Pi Zero. I'm using Mood, the operating system. I think on a future episode, I'm actually going to load multiple operating systems on different SD cards and do kind of a side-by-side comparison of them so we can understand what you gain and what you give up for different operating systems on the Raspberry Pi. But right now, I'm just going to hit the play button and try to get some sound coming out. You can see there's my channel, my scope channel. As soon as I hit play, sound's coming out. So let's switch back over so I can have a better view of this oscilloscope and get this signal scaled properly on the screen. So I'm zoomed way in, 100 picoseconds per division, which is a frequency much higher than the human ear can hear. So let's get out to a couple nanoseconds, or sorry, a couple milliseconds. That is going to be more in the hearing range, and it'll give us a little bit more time, which will allow us to see more of the sound. I can see that this signal is way off the screen, so let's scale this so that it actually fits on the screen. Okay, so now I have the signal scaled on the screen. I have sound happening, and I would like to make a measurement. So I'm just going to do a peak-to-peak measurement with some statistics on channel 1. And I can see that the max output with some sound going is looks like about 3.3 volts. I'm going to do a second measurement, so that's peak to peak. I want to do an RMS measurement. So click channel 1. Oh, gave me 2 measurements. I think we'll live with it. It looks like RMS 725 millivolts. Okay, so up to a volt. So about 3.3 volts peak to peak, and 1 volt RMS right now. How does that stack up to the analog output of my iPhone? I am going to delete these measurements really quickly to get them off the screen. I want to get a little bit more time on the screen. So let's crank up my acquisition time to something even longer. So let's say 200 milliseconds. That's a pretty long acquisition time. And so now I can see this sound waveforms pretty effectively. and I'm going to hit single, which gives me one acquisition on the screen, and I want to save that to a, if I can remember how to do this, to a reference waveform. So if I save waveform, let's go to load reference waveform. Update a reference waveform with the selected source. Okay, so now I have a reference waveform of my acquired waveform that I just grabbed. So I'm going to get channel 1 out of the way, and let's turn on channel 2. So channel 1, disable. Now let's hide the reference waveform for a second and hit go. Okay, so nothing is coming out of channel 2 right now. That's fine, because my iPhone is not playing any songs or anything or any sounds. So let's crank up some sound from my iPhone and hit run. All right, so now that'll probably help if I trigger on the sound output. And now let's scale this channel so it fits on the screen. A lot of scaling. It's a lot of scaling when you're using test equipment to make sure the signals fit on the screen. If they're off the screen, that's no bueno. If they're on the screen, that's bueno. That's good. So this signal is on the screen. And I want to, so this is 400 millivolts of division. I want to make some measurements on this. So I'll do peak to peak and RMS just like I did before. Let's see. 3 volts peak to peak. And the RMS is a little bit lower. So instead of a volt, it looks like it's about 500 millivolts. So a little bit less voltage in this guy, in my iPhone output. Let's save this output to the reference waveform. So let's actually do this properly. Math, reference waveform, setup. I already have reference 1 with channel 1. I'm going to do reference 2 with channel 2. So now I will have a stored waveform of both channel 1 and channel 2. I'm going to stop it, get channel 2 out of the way. So reference 1, I want to drag over here and look at the levels. It's a little tough to say using music because music itself has a lot of dynamic range. There's quiet signals and very loud signals. It looks like the loudest signals on both sides hit almost the same peak to peak, although you can see that reference 1 is larger than reference 2 on this particular capture. But we have a better way. We have a better way. Instead of just using music, let's use a tone. So before we were using tones, I'm going to delete some of these reference waveforms. Let's delete my measurements here. Drag this back over here. Delete measurements. Okay. Let's use a tone instead of just music, because music has so much variation in and of itself. It's very hard to use something that has a lot of variation inherently as a measurement reference to. So in order to make a really good measurement, you should have a very consistent reference that you start from. So I'm going to go back to the tone generator application that I have on my phone here. I was using it before, just called Tone Gen, and I am going to play a tone out of this foam. Tone out of the foam. Little Dr. Seuss. Little Dr. Seuss. There we go. Tone out of the phone. Tone out of the phone. So here's the tone out of the phone. This is 100% volume, so this should be as high a volume as I can get. Another thing that I want to do is I want to try to strip off the noise. So I'm going to turn on high definition mode. So that's going to strip off the high frequency mode, things that are outside of my hearing, because I don't really care about stuff that's outside of my hearing when it comes to my amplifier. In fact, I'm going to lower this even below a megahertz down to 100 kilohertz. So I'm going to strip off every frequency component that's above 100 kilohertz because my ear holes, remember, they only go up to 20 kilohertz. So this is a tone at maximum volume. If I go back over to my webcam, you can see here's the setup. So my tone, 107 hertz at 100% volume. If I go back over to my oscilloscope, let's see if it matches what I have sent into it. So I'm going to do a measurement. So we'll keep it on peak to peak. And I want to add a frequency measurement. So I have a frequency measurement. Let's turn it on. I can see 107 hertz. Pretty spot on. That is a pretty good indication that I'm making everything happen right. And for voltage level, it is 1.1 volts. So that is max output for 100 hertz. Okay. Let's see if that voltage range, that peak to peak range, changes as I change the frequency. I hope that it is flat. I hope that it remains 1.1 volts through the entire frequency range, but you never know until you test it. Welcome everybody into the chat. Thanks for joining. I appreciate it. Thank you so much for joining. Hopefully I don't bore you to death today. It is a Tuesday. It feels like Tuesday's episodes are just like a little bit more boring than maybe Friday's episodes. That's probably in my mind. Okay, so I changed the frequency to, let's see if it'll, where are you, webcam? No? No? You don't want to even focus there? I just don't know. I don't know about technology, guys. Mrs. OscopeWizard thinks I might have a bad frequency just inherent in my body that forces things to not work properly. I'm beginning to believe her. Maybe I should have been a plumber and not an electrical engineer. But I set the frequency. I'll have to tell you. I'll have to just tell you with my words. It is 1,113 hertz. I am measuring 1,113 hertz. So it feels like the frequency is pretty close. I am still measuring 1.1 volts peak to peak. All right, so that's good. So I went from 100 hertz to 1,000 hertz. Now let's go up to, I don't know, 16,627 hertz. Whew. Let's reset my statistics. Got a little bit crazy there. There we go, 16,600 and, uh-oh, where did I go? There I go, there I go. 16,627 hertz. Oh, hold on just one moment as I add a new camera since my, yeah, there we go. There we go. We'll just have to deal with that for a second. Sorry, guys. All right, so 16,627 hertz. And the voltage level is still 1.1 volts. So that's thumbs up, right? Thumbs up. Awesome. Great. So the iPhone output is 1.1 volts. Let's see what the DAC voltage is. Somebody's asking, what does 10 kilohertz sound like through your Raspberry Pi speaker? Oh man, well, it doesn't sound, it sounds like a very high-pitched buzz, but on the Raspberry Pi right now, I don't have a speaker hooked up, so I just have the analog output connected, but it is not actually connected to a speaker. It's not connected to anything except the oscilloscope probe. And we will, don't worry, we're gonna get this amplifier hooked up, and then we can listen to all the frequencies and tones from this DAC that we could ever dream up. I might need to wear earplugs that day when we do that, because it is going to be a little bit tinny. But I'll get there, don't worry. Okay, so now I want to send the same frequency. So I did 100 hertz, 1,000 hertz, 16,000 hertz, and I want to do it through the DAC. So I'm going to switch. So from, instead of channel 1, I don't really, or instead of channel 2, I don't really care about channel 2 anymore, so let's get it out of the way. Later, channel 2. Let's turn on channel 1. Sweet. Okay, so right now, oh, got some weirdness happening. That is not what I wanted to do. Let's delete my measurements. Okay, so channel 1 is still measuring the Raspberry Pi DAC output, and it is still playing music. So if I go back over to my desktop here, you can see it's still playing radio from the BBC One. I'm going to pause that, and I'm going to send a tone out. So the Raspberry Pi operating system, this Mood operating system, one of the things that it does is it allows the Raspberry Pi to act as an AirPlay receiver. So I am going to AirPlay from my iPhone that tone generator over to the Raspberry Pi. That's how I'm going to get the sound in. This is kind of one of the points of the project is I want to be able to AirPlay stuff from my phone to the Raspberry Pi. And you can see now AirPlay is active. And if I go back over to my scope, boom, here's the signal. So let's trigger on channel 1 instead of channel 2. You'll remember that the iPhone output was 1.1 volts. Let's see what the output for the DAC is. If I do the same measurements I was doing before, 2.4 volts. So over twice the voltage coming out of that DAC at 102 hertz. Let's see what I actually have it set at. 102 hertz. So that is spot on. Now if I change the frequency up to 1000 hertz or thereabouts, let's see what we look like. Okay. Now I am, let's clear the statistics. If I can read and speak at the same time, it's like talking and chewing gum, a very big challenge for me. But I have set the frequency. Okay, so the frequency now is 1197 hertz. My current is 1197. It looks like there was a little bit of a variation there, so occasionally I'm getting a faster frequency. That could just be cutting something off at the edges there. But still, 2.48 volts. So still way bigger instead of 1.1, 2.4. And now if I go all the way up to 16 kilohertz or thereabouts, let's see, I have it 16.92 kilohertz, 16.9217. That's pretty good. Okay, so 2.5 volts. You can see now I'm getting the occasional weirdness here. So it occasionally gets a smaller voltage on the output. That's weird. That is super weird. So up here at 16 kilohertz, still averaging 2.5 volts instead of 1.1 volts. But yeah, you see that? You see that occasionally popping around there? Huh. I wonder if I could use a trigger here. Do I have a trigger that could trigger on that? So if I made the upper voltage level 1.1 volts and the lower voltage level 1.1, oh, not 1.1, Gabe, minus 1.1 volts. So now I'm going to hit an upper level and a lower level. Oh, let's make that a little bit larger here. Can we trigger on this runt pulse? So a runt pulse is a pulse that's, you know, a runt. It's smaller than all the other pulses. So I need to, instead of auto trigger mode, when you're trying to find something that happens rarely, you need to turn it on to normal mode, because the way auto mode works is if it doesn't see anything, it automatically triggers. And we're trying to see if we can find something that happens rarely. Not really a... Oh, there we go. There we go. That is super weird. Huh. That's crazy. So if I hit stop and I go into History mode. So this lets me go back in time. I can go back in time. Okay, I can see what was happening. Okay, so there is, I'm still acquiring regularly. And here we go with the first runt. Huh. That is super weird. That is super weird. I don't know what that's all about, actually.
5 minutes remaining.
5 minutes left, so we're doing super weird stuff. We have 5 minutes left to try to figure it out. And then in the next episode, we'll actually tune the amplifier and then do some comparisons of the different Raspberry Pi operating systems. But I want to try to do a little bit more investigation into what would be causing these weird pulses. So honestly, it's the first time I've seen this. So we're seeing it live. You're seeing it with me. This is how debugging works. Now we're going to put our thinking caps on and try to figure this out. What would be causing these? Well, one of the first things we can do is we can throw on some cursors. Let's throw on some cursors and see roughly how big these pulses are. So how big is this pulse? And does that give me any indication of what it might be? Okay, my delta X is 7.8 milliseconds. 7.8 milliseconds. The one over that is 128 hertz. Let's zoom in a little bit. See if we can get a little bit more detail on this. Okay, right there. Let's call it 130 hertz, 7.7 milliseconds. Huh. I'm not sure what that is. Is each? Let's see if this next runt pulse is the same size. They look pretty consistent to me. Okay, 7.7 milliseconds. How about this guy over here? Oh man, where is my? Do I have a cursor set up? Turn them off. Turn them back on. No. Oh, cursors. Get into the zoom window for me. There we go. I thought maybe there was a button to gather him to the zoom window. I do not believe that there is. Okay. 1.3 or 7.7 milliseconds, 7.6 milliseconds, 130 hertz, 129 hertz. That is really interesting. It also looks like there's something even weirder, even weirder, if that is possible, happening right there. So if I do a second zoom, so now I'm just going to have zooms on zooms on zooms. Here we go. So you can see I have 2 super runt pulses right there, which is actually probably what I was triggering on. Interesting. I don't know, guys. I don't know. If you got any ideas what that might be, 130 hertz, 7.8 millisecond pulses that happen sporadically on the output of the DAC. Let's tell you what DAC it is. It is a TI PCM5102A digital to analog converter chip. I don't know what's going on there. The Raspberry Pi itself, I will say, the Raspberry Pi itself has a super noisy power supply, but this does not look like power supply noise because it is very consistent and looks more like digital output noise, which would lead me to believe that it has something to do with the digital to analog converter chip. I don't know. So that's it for today. We are gonna come back next week. Maybe we'll have some answers here. Maybe somebody will put something in the comments below for me to look at. Maybe somebody has some suggestions. Maybe my brain will work a little bit better when I am not live streaming and I'm just thinking. And we can hazard some guesses at what might be causing this behavior. Also, we will actually tune the amplifier in the next episode for this much higher voltage level. So this voltage level is twice the voltage level of the iPhone that we tuned the amplifier before. You know, we tuned the amplifier to handle the smaller voltage level, and now we got a much bigger voltage level, so we need to tune it a little bit better. All right. Oh, frame sync. I wonder if it could be a frame sync issue on the DAC. There's a lot of internal clocking happening on that digital analog converter chip. That is a good idea. I will take that and try to think about it a little bit. As always, thank you for watching. I don't know all the nerds in the world. Please share this with a nerd in your life, and I will see you guys next time. I'll hang out in the chat with you for a little bit, and see you on Baby Friday. Baby Thursday. Yeah, Baby Friday. I made it up, so I should know. Later, guys.